Hello folks, this is our part 5 video of this exercise 4.5. There was a major technical glitch and it couldn't be recorded yesterday. So since I had taken all the trouble to write it down, I will just go over it once again so that I don't have to write it down once again. We will be taking the problem number 13 and problem number 14. Now the problem number 13 gives us the matrix A. It gives us a matrix A and it asks us to show that A squared minus 5A plus 7I equal to 0. From there, they ask us to find A inverse. These are the two things that we have to do there. It's quite okay, yeah, because we know A, we will find out each of these elements and then we'll check whether it is that way or not. So what we do is, from A we get A squared. How? By multiplying A into A. So we have multiplied A into A, we do the normal matrix multiplication and we get the matrix A squared. It is this matrix. Then, because we require 5A here, we get the 5A matrix. How do we get the 5A matrix? By multiplying 5 with the elements of A. You are getting the 5A matrix. Now we are considering this required matrix, putting everything together, adding it up and getting the matrix as 0. That is what we require. That way, we have proved this. Now they are asking us to use that and find out A inverse. So we just do like transposition and get it. So what we do is, because we know that this equation is 0, we keep the 7I on one side, push the other terms on the other side. Now when we take the other terms, and also we keep the I and take the 1 by 7 on the other side, so that only I is there over here. Now when we take the terms on the other side, we observe that amongst both these matrix, A is a common matrix, so that we pull it out. So when we pull out the matrix A, we are left with this matrix 1 by 7 times minus A plus 5I. When A comes out, then 5I is left. So what it implies over here is, we know that A into A inverse is always I. That's how I becomes. Since A is there here, I is there here, automatically this matrix is the A inverse matrix. That's how we get A inverse as this particular matrix, which is 1 by 7 times minus A plus 5. All these matrices are known to us. We will put in the values, add or subtract and get the answer. So your A inverse matrix comes out to be this. So that is about the finding out of A inverse from the given A matrix. Next question is somewhat, I can't say identical, but somehow same. Maybe just the other way around, where here we were asked to show this, but here it is given that A squared plus AI plus BI equal to 0. That's given. Now from there they ask us to find out the small letter A and small letter B. So okay, right? As usual, we will from A find A squared, which works like this by matrix multiplication. Once we get the A squared, then because it's given that A squared plus AI plus BI equal to 0, we put in all the values to be equal to 0. And then we correspond each term, because it's a matrix. See, determinant, when two determinants are equal, we have to go in for the value of the determinant. But in matrix, it's not like that. Corresponding entries are made equal. So this entry is equal to this entry, this entry is equal to this entry, this is equal to this, and this is equal to this. And you take that entry which can give you the answer. For example, A plus 4, which is 0, make it equal to 0. You're getting the A value as minus 4. Then you take this also has to be 0. 3 plus A plus B equal to 0. There you put in the values of A and finally get the B value as 1. So we are getting A value as minus 4 and B value as 1. That's about it. And this is our part 5 video. Part 6, they are all huge problems. So with those huge problems, we come in the next part. Thank you.